Flight 12 hardware is complete. Starship V3 upgrades are locked in. SpaceX has quietly mapped out 8 launches for 2026, but one of these missions will attempt something no aerospace company has ever achieved in the history of spaceflight. Will it be the first dual-stage catch at Starbase? The debut of orbital refueling? Or something else entirely that could redefine what's possible? Let's find out on today's episode of New Space Review. Right now, Starbase looks oddly quiet. Both B-19 and S-39 are structurally complete, something that would normally trigger an immediate rollout to the Massey test site. But they're not moving. SpaceX crews spent the first week of January doing something completely different. Installing the final piece of Pad 2's quick disconnect system. On January 6th, the QD arm extension rolled out in the early morning darkness. By noon, a massive crane lifted it into position. This wasn't just another ground system upgrade. This was the last critical component Pad 2 needed to become fully operational. The intricate network of propellant lines, valves, and interface panels shows one thing clearly. This system is designed for high-cadence operations, not test flights. SpaceX could have rushed Flight 12 in late December. They chose not to. Why delay when hardware is ready? Because 2026 isn't about one spectacular test flight. It's about building the infrastructure for 8 launches that will fundamentally change what Starship can do. While Pad 2 was getting its final systems, something unusual appeared at Massey. A ring section nobody had seen before, combining the ship skirt and can crusher interface, was suddenly lifted onto test tank B-18.3. The part that caught everyone off guard? They placed it directly on top of the hot staging assembly. Under normal conditions, nothing goes above the hot staging ring until you're stacking for an actual flight. So, what's SpaceX validating with this test? The new hot staging design takes inspiration from the Soviet N-1 rocket. Simpler, lighter, with better heat dissipation. But simplicity creates a new engineering challenge. This ring now carries the entire load of a fully fueled Starship. We're talking about 1,300 tons of mass pressing down during ground operations, launch, and ascent. Any structural weakness doesn't just cause a failed landing, it causes a catastrophic failure during the most critical phase of flight. SpaceX is testing the interface now, weeks before Flight 12, applying lessons learned from B-18's stress test failures. They're ensuring V3's foundation is bulletproof before committing to a launch timeline. Let's be honest about the schedule. A late January launch was always optimistic. B-19 still needs to roll to Massey for cryo testing, return for engine installation, and complete static fire. S-39 follows the same path. Then both stages move to Pad 2 for integration. Even if everything goes perfectly, no leaks, no sensor anomalies, no weather delays, you're looking at mid to late February. That timeline might actually be better. SpaceX isn't just preparing Flight 12, they're preparing for a year where Starship transitions from experimental test vehicle to operational launch system. Rushing Flight 12 and failing would reset the entire roadmap. Taking an extra 3 weeks to validate V3's architecture? That's not a delay, that's strategic discipline. Meanwhile, NASA just confirmed Artemis 2's launch date, April 6th, with a backup window extending into April. The SLS stack should roll out to the pad in mid-January for integrated testing. Which mission flies first? Flight 12 or Artemis 2? NASA's confidence is high, but SpaceX has a track record of compressed timelines. This race just got real. Flight 12 is the opening move. Full Raptor 3 engine suite, redesigned heat shield, upgraded grid fins, and validation of hot staging under the new V3 architecture. Both stages land in the ocean, not because SpaceX can't catch them, but because proving the upgrades work takes priority over reusability demonstrations. If Flight 12 succeeds, Flight 13 becomes the moment Starship officially reaches orbit. Not suborbital, not nearly orbital, true orbital insertion with sustained velocity. Why does this matter? Blue Origin's New Glenn and China's Chuche 3 have already demonstrated methane-fueled orbital flight. SpaceX cannot afford to be third in the Methalox race, not with Starship's scale and public visibility. Flight 13's trajectory could extend beyond the Indian Ocean, potentially targeting a Pacific or Atlantic landing. This longer flight path tests thermal protection across multiple orbits and validates navigation accuracy for eventual return to launch site operations. Then comes Flight 14, and Starship stops being a test vehicle. Real Starlink V3 satellites. Not mass simulators, not dummy payloads. Actual operational hardware worth millions of dollars. Deploying 100 satellites in precise orbital slots without collisions requires navigation accuracy SpaceX has never demonstrated with Starship. One miscalculation creates a debris field instead of a constellation. But if it works, Starship just became a revenue-generating asset. The economics of the entire program change overnight. Full two-stage recovery at Starbase. Mechazilla catches the booster at Pad 1. Minutes later, Mechazilla catches the ship at Pad 2. No ocean landings, no compromises. Both stages return home, get inspected, and prepare for reuse. This is the capability that makes Starship fundamentally different from every rocket ever built. Falcon 9 recovers the booster. Shuttle recovered the orbiter. Nobody has ever recovered both stages of an orbital-class rocket and had them ready to fly again within weeks. Catching the booster is now routine. SpaceX has done it 3 times. Catching the ship? That's exponentially harder. The ship travels farther, endures peak re-entry heating, and must maintain structural integrity while decelerating from orbital velocity. The heat shield can't have gaps. The flaps can't have burn-through. The propellant margins have to be perfect. If Flight 15 fails, SpaceX has a problem. If it succeeds, they've unlocked rapid reusability, and the economic equation changes for every competitor trying to keep up. Flights 16 through 19 focus on one capability: orbital refueling. Without it, Starship can't reach the Moon, can't reach Mars, can't do anything beyond low Earth orbit with meaningful payload capacity. Elon Musk confirmed SpaceX will conduct multiple refueling demonstrations in 2026 using V3 hardware. The complexity is staggering. Docking 2 massive vehicles in orbit, transferring cryogenic propellant in microgravity, maintaining thermal control, and proving the process is repeatable and reliable. Early attempts might not be back-to-back launches. SpaceX could fly one long-duration mission to test propellant storage, then launch a second vehicle weeks later to perform the actual transfer. 4 flights give them room to iterate, fail, learn, and succeed. While SpaceX refines Starship, China is pouring money into reusable rockets. Landspace just filed for a $1 billion IPO to fund Chuche 3 development after their debut landing attempt failed. Long March 10A, a Falcon 9 clone with a 5-meter diameter, is targeting its first reusable flight this year. Copying the design doesn't mean you understand the engineering. Chuche 3 reached orbit but failed during landing. Long March 12A's booster recovery attempt also failed. Space Pioneer's Tianlong 3 had an unplanned launch during a static fire test. These aren't minor setbacks. They're indicators that reusability is harder than it looks. SpaceX spent years mastering booster landings. China wants to compress that timeline into months. They might succeed, but throwing money at a problem doesn't guarantee results, especially when your development strategy is reverse engineering someone else's decade of hard-won experience. By the end of 2026, we'll know if China's investment paid off or if they're still years behind SpaceX's operational maturity. So what does 2026 really mean? SpaceX isn't racing to launch Flight 12 in January because they're chasing headlines. They're building the foundation for 8 missions that will prove Starship can do what no rocket in history has ever done: recover both stages, refuel in orbit, and fly again within weeks. Flight 12 validates V3. Flight 13 reaches orbit. Flight 14 deploys real payloads. Flight 15 achieves full recovery. And Flights 16 through 19 master orbital refueling. Each mission builds on the last. Each success unlocks the next capability. This isn't a test program anymore. It's the roadmap to making humanity a multiplanetary species. China's pouring billions into catching up. Blue Origin and Rocket Lab are pushing their own reusable designs. But SpaceX has something nobody else does: operational experience, proven hardware, and a launch cadence that's about to accelerate beyond anything we've seen. By December, Starship will look completely different. The question isn't whether SpaceX can do this, it's how fast they pull it off. If you're following this journey with us, hit that like button and subscribe to New Space Review so you don't miss what happens next. Drop a comment with your Flight 12 launch date prediction. I'm reading every one. Thanks for watching, and if you want to see how SpaceX is already solving critical ISS challenges while Starship develops, check out the video on your screen right now. SpaceX found perfect solution to Russia's ISS threats. Mind-blowing 19-minute burn. You won't believe what they pulled off. See you there.